In this tutorial, we'll learn how to create a Railclone style from the ground up. We'll work with a railing model similar to the one used in the foreground of our Railclone 6 release image. So we'll start with a simple mesh, which could be an asset you've purchased, a model you've created, or something you've imported from a library like Chaos Cosmos. Our aim is to convert this static, dumb mesh into a smart parametric Railclone object. First, we'll add a new Railclone Pro object to the scene. Then go to the style rollout and open the style editor. For a Railclone style that uses a path, you'll need to add a minimum of 3 nodes. The first node you need is a generator. Essentially, this is the brain or the rule set that determines how you distribute geometry along a spline in an array. There are just 2 types of generators. The L1S, which stands for Linear One Spline Generator, which creates a 1D array along a single spline. Or an A2S, which is an array 2-spline generator, which creates 2D arrays for when you want to parameterize the height as well as the path. In this tutorial, we'll use the linear generator, the 1D array. So the second node you need defines the path for placing your geometry. You do this by using a spline node. Wire the spline node to the spline input of the generator and then select a path from the scene. And finally, the third node is used to assign some geometry from the scene to the spline. We'll start by distributing a single object along the path. To do this, add a segment node and then pick the railing object from the scene and wire it to the default input of the generator. At this stage, your Railclone object will distribute the chosen geometry along the spline, and a simple style is complete. So to customize how this default geometry is distributed along the spline, you can head over to the generator's properties tab and find the rules section. Here you'll have several options at the top. You've got tile, which is the default mode and places the geometry along the spline without adjusting its size. When it reaches the end, it just cuts off the excess. Adaptive mode subtly rescales the geometry to ensure that only whole segments fit along the spline. Scale stretches one segment along the whole length of each subspline. And finally, count allows you to specify exactly how many objects you want along each spline. In this case, we'll use adaptive to avoid slicing. So far, it's all fine, but it's not really a very parametric style. If you want to create something a bit more sophisticated where you can adjust the spacing between the posts with a continuous welded handrail, then we'll need to slice the original mesh into pieces that the generator can then reconstruct like a jigsaw. This can be done using the new Railclone Slice modifier introduced in Railclone 6. So to do this, select the model and apply the Railclone Slice modifier. This modifier is specifically designed to work with the 2 generators we mentioned earlier and uses the same terminology and creates all of the necessary components. To use it, start by defining a slice plane at the beginning of your railing model. This can be done numerically, or you can go into the sub-objects and select X start to adjust it using the mouse. Repeat this process to create an end slice. You'll also need additional slices in the middle to isolate the vertical posts, and you can adjust these using the evenly sliced plane and then by adjusting the width setting. Finally, created using the same 2 sets of parameters, you need a default section to fill in between all the others. This is a simple blank section of handrail. After defining all your slices, you have the option of previewing them. This can be done at the bottom of the Slice modifier menu by clicking Export Slices. These are the components that will be used to recreate the mesh parametrically, but actually there's no need to have individual objects like this in the scene. Instead, Railclone can extract them automatically from the source geometry thanks to this new modifier. In the Railclone Style Editor, pick the segment and in the properties, change the Z alignment to pivot. This is to ensure that the pieces jigsaw together correctly and align on the Z axis. Next, detach the node from the default input and wire it to the start. In the Properties panel, select the original mesh with the Railclone Slice modifier applied and scroll to the bottom of the interface to find a new option called RC Slice. Here, you can select which slice to output from this one node. For instance, select Start to only output the beginning of your railing. You can see it here at the start of the spline. Now clone the node and wire it to the end input and change the source to end. Now you can see it at the end of the spline. Repeat this process for the default input and the X evenly input. You will now have a much more flexible parametric railing. With your railing created, you can adjust the width between the verticals simply by going into the Rules tab once again and changing the evenly distance parameter. Now, as you can see, corners are created by default by simply beveling the default geometry to follow the spline. You do also have several options here, which are best illustrated if we temporarily add the whole railing segment back to the default input, remove the evenly input and set default mode back to tiling. Now we can see more clearly the options we have to determine how this segment wraps around the corner. So first of all, we've got reset. This slices the segment before the corner and starts it again after the corner. Next you have extend, which continues the segment around the corner, maintaining the segment's original length but wrapped around the vertex. Then we have symmetrical, which ensures the size of the segment after the corner is the same as that before the corner, creating a symmetrical composition. And of course we also have none, which turns off beveling completely and instead tries to bend the geometry around the corner. So those are our corner options for the default geometry, but you can also add geometry specifically to the corner. To illustrate this, let's put this style back together how it was with adaptive distribution, the default slice, and the evenly input reattached. Now, our source model didn't specifically have a corner included, but we can use some of the slices we already have as a substitute. For example, we can add the existing evenly segment to the corner. Now it looks a bit odd, and that's because it's trying to bend the geometry around the corner. Let's bevel it instead by going into the generator settings and enabling bevel corner in the Rules tab. Now the geometry is applied to each side of the corner and beveled where they meet. You can adjust the bevel location using the BC offset parameter. And a final thing I want to mention about the corners is the use of compose operators with bevel. Let's imagine you want to end the railing before the corner, creating a gap, and then start it again after the corner. To do that, you can add a compose operator, which allows you to combine segments to form new geometry. We'll add one to the corner input and then wire the end segment to its first input and the start segment to its second input. This creates the correct geometry in the right order, but it's not aligned to the corner how you'd imagine. This is because there's an even number of inputs, so Railclone centers the geometry to the first segment in the compose node. To take more control, add an empty segment to the second input of the compose operator. When an odd number of inputs is attached to a compose operator, the center geometry is always used to align to the vertex and the positioning is correct. You can even change the X size of the empty segment to control the size of the gap shown at the corners. The beauty of this approach is that now we've got our first parametric railing complete, you can easily create more by duplicating the graph and just using different source geometry. For this, you'd select a new object and use the Railclone slice modifier to cut the model into pieces just like we did before. Since we've already done it once, I'm speeding up the process. Then you simply copy your existing Railclone object, open its graph, select all of the segments and replace the source with a new object. That's it. Repeat the process as needed to create a variety of different parametric railings all based on this existing graph. And before I go, I just want to wrap this up by showing how easy it is once we've made these to add them to the library in Railclone 6. Just open the library browser, right click on your user library and choose Create Library. Or you can simply use an existing user library if you prefer. Then you right click on the library to rename it if you need to. Next, select the Railclone objects from the scene, then right click in the library and select Import Railclone Objects from Scene. Change these settings, which are pretty self-explanatory, and then click Import. In a short while, the new assets are in the library and available to use anytime you need them.